All right, good morning and assalamu alaikum. We are going to start today from the topic how scientists invented the batteries. Yes, good morning to you, Nasser, as well. So, this is the module 4. We are working on module 4. This is lesson 2, the second lesson for the week. So, let's begin. And there are some more participants walking in. Okay, so let's start the presentation. Bismillah. This is the topic. We're going to be looking at one of the, historical uh, events, you can say historical point of view, that how the scientists were able to invent the batteries. They wanted to have, resources of power that was you know, under discussion, and they wanted to know how that we can actually have some source of energy which is stored in a box so we can utilize it later. So let's start and see how did they actually invent. Before we go to the invention of the batteries, we're just going to have a small introduction about what are the batteries. So let's go with Abdullah Ashraf. You have the mic. Can you read
Good
that slide
morning.
for us? Good morning. How are you?
How scientists invented batteries. Batteries are a collection of one or more cells whose 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 chem, chemical reaction creates a flow of
Chemical
electron
reactions.
chemical reaction creates
Well,
a flow of electrons in a circuit. All batteries are made up of three basic components, and anode the side.
the negative
A
side, it's showing us the negative.
negative,
There's, yes,
negative side. A cathode the positive side,
very good.
and and electron and electron electrolyte
Electrolyte,
electrolyte a substance what chemically reacts with the anode and cathode.
all right, so let me explain
What's
that
what
slide for you. Yes, what is your question?
what does the cathode and anode and electrolyte?
Okay, when we are looking at the battery, there are three components that you can see, right? Number one is the positive side, and then there is a negative side. If you look at any battery that is available on the market, you're going to find that they have two sides of it. One is being marked with the positive side, and one is marked with the negative side. So the terms, the scientific terms that we use for that battery is actually called anode and cathode. Anode represents the negative side of the battery, and cathode presents the positive side. Now, the third thing which is inside these cells is known as electrolyte. This is the substance inside which is storing the energy, which is storing the electrons, which enables the flow of electricity when you connect it to a circuit. So these are the three things in a battery. What is that electrolyte made up of? That is going to be discussed in higher grades. You're going to find out that what kind of chemical reactions happens, how do they release the energy, how do they store the energy. This is going to be discussed in higher grades. But right now,
So
yes.
so electric light means the thing that's inside the cell.
Yes, the electrolyte is that chemical inside the cell which stores the energy. And once you connect it to the circuit, it will flow the electrons out. It will give you the energy back to you. Right?
Thank you.
Very good. So Bilal Ahmed has a happy face. Okay. And Saria is still saying that he's unable to hear me. Anybody else who is unable to hear me, please raise your hands. I'm going to lower everybody's hand. And just please answer to me this, that if you're unable to hear my voice properly, Then raise your hand. Majdi and Saria are the two people who can't hear me well. Check now, please. Can you hear me now? Is the voice better? Okay, good. So this is done. All right, Saria says yes. Thank you, Saria. So we are looking at the battery. So these are the three things according to the modern science. Now we have three components. One is a positive and negative terminals, and then the chemicals inside, which we call electrolyte. They are going to be utilized for storing the energy and for releasing the energy. Bilal, Saria was mentioning that he's unable to hear me properly. Not that he can't hear me at all, but he said that the voice is not that good. So let's go to the next student. Badr needs to read the next slide. Badr, you have the mic. Can you please read?
How scientists build batteries. All the circuits you have made have include cell or a battery. These batteries contain chemical substances that reach together. This reaction supplies the energy needs to push the electricity around the circuit. How did scientists make this discovery?
All right. So, Badr, I'm sorry that there was a little bit of breaking of the voice. Maybe my internet is slow or something like that. So I'll give somebody another chance to read that slide so we can hear him properly. Bilal, you have the mic. Can you read that slide again, please? Bilal, you have the mic.
Yes.
Can you please read that slide again?
Okay. 1 minute. It's zoomed. Okay. How scientists invented batteries. All the circuits you have made have included a cell or a battery. These batteries contain chemical substances that react together. This reaction supplies the energy needed to push the electricity around the circuit. How did scientists make this discovery?
All right, excellent job. So we were discussing previously on the previous slide as well that circuits, once it is a closed circuit, the battery starts to give out the energy. They contain the chemical substances that do a small chemical reaction slowly, and it keeps on giving you the supply of energy that you need in that circuit. If you need to glow a bulb, the bulb will start to glow. If you need a buzzer or a motor, so all these things will start functioning once you connect them to a circuit. So how did scientists actually make that discovery? We have to go back around 2,000 years. So Elias, you have the mic. Can you please read that slide for us?
What did you say, Master?
Can you please read this slide for the class?
Okay. The Baghdad Battery. In June 1936, workers found an 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 an
Ancient.
antique an ancient an ancient bomb
Not bomb.
while
Tube.
a tomb while they were constructing a new railway near the city of Baghdad. In present day Iraq, archaeologists identified things in the tomb to be 2,000 years old. At this time, people called the Parthians lived in this region.
Parthians. All right. Thank you, Elias. So back in 1936, people were trying to make a new railway track in the city of Baghdad, which is in Iraq. So while they were constructing the railway, they were able to find a big tomb, an ancient tomb, a very old, something like this. You can see this, it's about 14 centimeters tall. The picture that you can see on the right side. Let me grab my pointer. So this thing is about 14 centimeters tall. They were able to find this, and then they sent it to the archaeologists to find out that how old is it. they were able to find out that they were 2,000 years old. And 2,000 years ago, the people who were living in that region of Baghdad were known as Parthians. Now, what is this device going to do? Let's see. Let's go to the next slide. Let's read more about it. And we have Laith. Okay, Laith, do you have the mic?
The Baghdad Battery. One of the
Yes.
old objects or relics they found in the tomb was a clay jar. The jar had an iron rod coming out of the center.
All right, we
Just
have
made
two
copies of
boys
its
who are using the
relic.
video, and I'm
What?
gonna remove them. This is the last warning if you're using a video in the session. All right.
When they filled the tube with an acid such as vinegar, it produced between 1.5 and 2 volts of electricity between the iron and the copper. Our archaeologists think that people who lived 2,000 years ago could have used batteries like this to cover metal objects with gold.
All right, good.
Can I-
So one of the old objects or relics they found in the tomb was a clay jar. The jar was made up of clay. The jar had an iron rod coming out of the center. So if you look it closely, you're going to find there was an iron rod surrounded by a tube made of copper. So let me try to draw this thing over here. If you're looking in the middle of the section over here, this is what you can say the middle part was made up of the iron, and the surrounding part was made up of copper. So there are two parts of it. Copper surrounding it, and the middle part is the tube. Okay, so next what happens? When they filled this tube with an acid, what kind of an acid they were using? They were using a vinegar. It produced 1.5 to 2 volts of electricity between the iron and the copper. So this was one of the first most prehistoric type of cell in that era. Bilal, somebody's playing PS4, so what can we do about it? I can't see anybody playing PS4 with me. So, okay, so Laith, thank you for your participation, and let's go to the next paragraph. Archaeologists think that the people who lived 2,000 years ago could have used batteries like this to cover metal objects with gold. It was very common at that time to cover the objects with gold. They would take the gold in a liquid form, and then they would, dip it inside, use the electricity, and the electricity helps them to connect with that metal. It becomes like a sticker. It would cover the whole object with the gold water. So this was the old practice. They had ornaments which were covered with the gold. So that's one of the logical, explanation that why did they need batteries at that time, 2,000 years ago. All right, Ibrahim Ismail, you have the mic. We're going to the next slide. Let's
Yes,
read
Mr.
this. Great.
Do I read?
Yes, please.
Luigi Galvani was an Italian doctor about 1780. He discovered current electricity. He hung a frog's leg on copper hooks over an iron railing and noted that the leg muscles twitched. Galvani was correct when he said that the twitching were caused by electrical current, but he thought that the current came from the frog's leg nerves and called it animal electricity.
All right, Luigi Galvani, he was the first Italian doctor in 1780. What did he do? He took the frog legs and he hung them up on copper hooks over an iron railing. And then he noticed that the muscles were twitching. By twitching, it means that they were moving up and down, a little bit slow, sometimes very fast. Galvani was amazed to see that, and he thought that maybe these, the electrical impulses which are being created in the legs of the frog, they are happening because of the, animal electricity, because of the muscles. They contain, electrodes as well, and maybe he was able to, get the electricity out from that point. So he called it animal electricity. He wasn't perfectly, correct, but he had a good idea that the even if the body is not connected, you can see the only legs are hanging. The upper part of the body is not connected. So if we connect them with the different copper and iron, they will still move up and down. So why did this happen? Let's go and find out on the next slide. And we have Abdul Malik Shams. Shams, you have the mic. Let's go to the next slide. Abdul Malik, you have the mic. Abdul Malik Shams, are you with us? I think he's a bit busy. Let's go to Laith. Okay, Laith, you have the mic.
The Voltec Battery. Alessandro Volta was an Italian university professor. He repeated Galvani's experiments many times with different materials. From these experiments, he came to the conclusion that it was the two different materials, copper and iron, not the frog's leg that produced the electricity. The frog's leg contained a fluid which conducted the current. It twitched because the electricity was flowing through it.
Oh, very good. Thank you, Laith, for your participation. Now, this is the explanation of why the legs were moving up and down. So Alessandro Volta was the Italian university professor. He did this experiments many times. He used many different materials. He tried with the aluminum, he tried with the bronze, but he finally concluded that it is the copper and the iron which are conducting the electricity well. Now, why these legs were moving up and down? Because there's a fluid inside the legs of the frog. The frog was not alive, Abdullah Ashraf. We are only using the legs. The upper part has been taken off. The frog is dead. And there's a material, there's a liquid inside. Even we have it, that liquid, in our spinal cord, which helps us to, send messages to and forth to our body, different body parts. And we can move our body because of these small electric impulses. We don't have the electric impulse like strong enough like in the mains of electricity, but we have about 1 volt to 2 volts in our body, which helps us to understand there's something touching our body or something which is harming us, or we can feel the touch and the sense they are being conducted by that liquid in our body. So the frog got the electric shock, yes, and because of that electric shock, its muscles, its legs were moving up and down. All right, the legs were moving up and down because of the flow of electricity. So similar flow of electricity is in our bodies when we move our body parts, when we run, when we move our hands, raise our arms and legs. So this is quite similar to us as well. So he was able to identify what was the main point that he concluded, that it's not the animal electricity, but it is the conduction of the electricity in the body, in the animal body. Okay, so we have next slide. Let's go to the next slide, and what's his name? Saria is raising a hand. Saria, you have the mic. Let's go to the next slide.
Yes.
Yes, can you please read that slide for us?
The first slide,
Yes, please. The first slide.
the walls failed in 1000.
Yes, please carry on. 1800.
1800 after main experiment.
Many
Many ex-
experiments.
many experiments. He developed a type of battery that he called the
Voltaic pile.
Voltec pile.
Very good.
This caused of a pile of zinc and
Copper
copper
discs.
disc copper disc
Right.
between which disc there was a piece of cable that he had soaked in salt
Salt water.
water aware
A wire.
a wire
Yeah.
contain the boat seals. This to the top copper disc called
Could produce
produce a conductor's flow of
sparks.
sparks.
All right, thank you, Saria. You need to practice to read at home. You have to do a lot of reading at home, practice it so it can get better. Ahmed Abu Judail, you have the mic. Can you please read that slide for us again?
Okay. In 1800, after many experiments, he developed a type of battery that he called the Voltec pile. This consisted of a pile of zinc and copper discs
Okay, so
between
who is he, that person we are talking about? After that many experiments, he developed a type of battery. Who is this he guy?
um
What were we discussing about in the previous slide? Alessandro Volta, the Italian university professor. This is the guy who kept on doing many experiments, and then he was able to find a way to create a battery which is called as Voltec pile. It consists of a metal, zinc, and copper discs. Okay, so what's happening next to the second point? Please read this one.
between each disc there was a piece of cardboard that he had soaked in salt water. A wire connecting the bottom disc, zinc disc to the top copper disc could produce a continuous flow of sparks.
Very good. Thank you very much. Now, what is happening over here? Let me show you the diagram. There are two kinds of metals. Let's say this is my zinc. This one is zinc, Z. This one is copper, C. And this one is a cardboard. This cardboard contains the water and the salt inside. So once you put them all together like this in a stack, they would produce a continuous spark because the water and the salt, the zinc and copper were reacting, and they created sparks. And if you connect two wires over here and here, then you have the electricity. You can say this is my positive terminal and this is my negative terminal. This becomes my anode and this becomes my cathode, and then it becomes like a big cell. Yes, Nasser, do you understand now? And Abdullah Ashraf, you're correct that this is like a big cell. So all of these plates are acting like, metals, This one becomes by positive terminal, this one becomes by negative, and the water and the salt with the cardboard becomes like an electrolyte. So Bilal is saying that he didn't understand the frog part. So let's go back to the frog. Let me show you only one thing. Look, once you connect the copper and the iron together, they try to conduct electricity. The electron starts flowing in. Once they go into the legs starts to move up. They move up and down as if they're alive. So the first guy, what was his name? The Luigi Galvano, he thought that this is happening because of there's an electricity inside the frog. There's electricity inside the muscles. And he called it animal electricity. With the passage of time, we learned because of Alessandro, he discovered that it is not the animal electricity, it's actually the electricity between the copper and the iron. And these muscles were moving up and down because the electricity was conducted through it. The electricity passed through these muscles. Once they pass through these muscles, the muscles contract and relax. They move up and down. And we know this is happening because there's a fluid in the legs of the frog. That fluid helps the electricity to get conducted. That's why they move up and down. And this is the same fluid that we have in our body, which helps us to move our muscles up and down as well. We let them contract and we let them relax because of these fluids. All right, good job. So Majid has a question. You're raising your hand. You want to read or do you have a question? Majdi, sorry. Majdi, you have the mic. Majdi seems to be not with us. I'm going to lower his hand. Ibrahim, you have the mic. Let's read the next slide. This one.
Okay, so
Thank you.
the vault pile. Vault bullet different piles using 30, 40 or 60 discs. He measured
Yes.
the reaction with different numbers of disks and discovered that the electric shock increased in intensity with the number of disks he used in the pile. Later, scientists improves Voltec batteries by doing more experiments.
All right, good job, Ibrahim, but you need to practice on reading. All right, so we'll give Abdulaziz a chance. You have the mic. Yes, Abdulaziz, can you read that for us, the slide?
Yes, Mr. Later, scientists improved Volta's battery by doing more experiments.
I want you to read from the top.
Volta built different piles using 30, 40, or 60 disks. He measured the reaction with different numbers of disks and discovered that the electric shock increased in intensity with the number of disks he used in the pile. Later, scientists improved Volta's battery by doing more experiments.
All right, thank you. Let me explain that part. Now, Volta, what he did, he started using more, disks. He started with 30, he increased it to 40, and then he increased it to 60. What he was noticing that if he keeps on increasing these disks, the electric shock intensity was also increasing. If you would get a small shock with 30 discs, if you put 60, you'll get the double amount of shock. So the electric shock were also getting intensified. They were getting more in power. So he was measuring these electric shocks with the different materials like ammeter. We have these days, we have ammeter and voltmeters. At that time, we didn't have those meters, but he was experiencing with the different, meters for doing an experiment, a simple experiment like collecting the gold, melted gold on an object. If it was with 30 discs, it would happen in like 5 minutes. If you put 60 discs, it would be done in like 2 minutes. So it had more power, more electric shock was generated with the number of these discs. Now later the scientists improved the Volta's battery and they kept on doing more experiments and they were able to understand that how it works. So this is about the, this was the history of the inventing of the batteries. And yes, Abdullah Ashraf, you're right. A cell is a small battery. And that is correct. We were looking at the invention, how did the scientists were able to invent a battery. This was the historical lesson. And we are almost finished. If there's anybody who's unable to understand, please raise your hand. I'm going to lower everybody's hands. And I'm going to see if there is any confusion, you can ask. So starting with Bilal and Abdullah. Okay, Abdullah, you have the mic.
Mr.
Yes.
I just sent you the message. You said yes, that a cell is a small battery.
Yes, that is correct. So thank you. Yes.
Is it made like the same of the big battery or from what?
What is made of the same battery?
The cell.
The cell, the one which we read about, the Voltec piles, these are the old batteries. We don't use them anymore. This is the beginning of making a cell. If you're looking at, yes.
From what are they made?
Copper and zinc. These are two metals. Water and salt. This is the electrolyte which lets them react.
Copper and zinc?
Copper, zinc, water, and salt. These all four things together will be.
What is a zinc?
Zinc is a metal like iron, aluminum, copper. These are all metals. They are different because they have different atoms. They have different number of electrons. So inshallah, we'll study them in higher grades. That what makes a zinc and what makes a copper. Why are they different? Still, they are metals, but why do they behave different when we put them into different scenarios?
Thank you.
All right, thank you, Abdullah. So we're going to the last question because the time is up. Yes, Bilal, what's the question?
Yes, Mister. Mister, again, I don't know what is a zinc and a copper.
Like Abdullah was also confused, the brass, the aluminum, the copper, these are all different kind of metals. They have the ability to conduct electricity. So
But what is copper?
they are all metals. They are solid, they are shiny, and they look like iron, but they are not iron. They have a different number of electrons in their atoms. They have different number of protons. So they have different properties, different melting point, different, chemical reaction properties. So they are all metals, but they are different, a little bit different from each other.
Okay.
All right. So if you'll go to grade 9, you'll study about these metals, the configuration of the metals, how do they, how they are different from each other, why they are different from each other, and how many electrons they have. So you're going to study in grade 9's chemistry about all these objects. All right?
Okay.
All right. Thank you, Bilal. So boys, this is it. We are done for today's lesson. And I hope everybody has understood. Yes, Abdullah Ashraf, you're correct. They're all metal, M-E-T-A-L. They are all metal. And Abdulaziz, I'm sorry, we are done with the time. You can send me the question over the email, and inshallah I'll try to answer them. Plus your homework is pending. You have to submit your homework. I'm looking at a lot of boys are not doing their homework.